We'll start looking at perspective with a simple one source perspective, 1 point perspective. And you may be aware of this, but let's just run through it again. If we create what we call a horizon line, so I'm going to put this right across the page here. That's called the horizon line. Also our eye level line. So our eye is at that level, as it were. What I'm going to do is place on that a little vanishing point. So we'll just make that dot represent the vanishing point. Let's say then we create a line that indicates the side of a wall, or it could be the edge of a box, the corner of a box or whatever. So we place it there. So it's pretty smack on our eye line. Then, of course, from there on, we'll put some guidelines in here. So that line runs to the vanishing point. That line runs to also the vanishing point there. So we can see the illusion beginning to happen of the railway tracks or whatever. Let's put in now another side to this shape, this wall, this whatever it might be. So there's our face of our wall, or side of a box or whatever it is, and that will be running back into space. Okay, so from here on in, anything, I'll just change maybe and use a pencil for this, anything on that plane, on that piece of card or brick wall or whatever that is, it's running back, will have to run to the vanishing point. So I'm placing my ruler at the vanishing point. For instance, let's say in the wall there was a window. So if I want the window, the bottom of the window has to run back to the vanishing point. The top of the window, wherever we choose that to be, let's say there, also has to run back to the vanishing point. We'll just create a couple of verticals there to finalize that. So put that there and here, and we create a space there that would be a window, but you can see that it's all falling into that point. One of the mistakes, or one of the omissions a lot of people make, is that they create the walls, the side of a wall or whatever it happens to be, and when they try to put windows in, they don't use a vanishing point, or they guess it or whatever, and the result might be that the wall may be running back in perspective, but sometimes the perspective of the window is completely wrong. It's either straight on or maybe even slightly out. So I'm giving you an example, and you know, if you've done this, you may have found yourself struggling with this. So you have a situation that doesn't seem right because it looks skewed in some way, that we forget that everything along that plane must all radiate, hinge like that around that point. Of course, it goes without saying, you can see in my guidelines here, that all the vertical objects that are moving along this plane towards the vanishing point get smaller. And we're going to talk a little bit more about that, or a little bit more about the distances between things, but I just want to put 2 or 3 more lines in there just to let you see. So railway tracks or railings or whatever it is, they obviously get smaller. So now what I want to look at is a 2-point perspective, twin point perspective. So this time, and it's a simple development from the previous little exercise, I'm going to draw a line again, a horizon line, as we did before, but this time what I'm going to do is place 2 points on that line, and they are the 2 vanishing points, if you like. Now what I could do in the middle here is place an object. Let's say it could be just a line there, and it can be positioned here, and that could be, let's say, the corner of a building or whatever. So therefore, if we join the top of that line to that runs off towards that direction. As with the single perspective, it runs into a single point. But this time, because we are dealing with a second flat plane running off in a different way, it's running to a second point of disappearance. So we have this sort of illusion, almost like a kite on its side. But you can see the illusion of these things running back, because this time we're looking at two faces of something. Let's say, for instance, I turn this into more like a building. Okay, so I'm going to put the second wall in the end of the building, if you like. There's the corner, there's the other end of the building there. So what we've got is a box, I guess, if you look at that. If I thicken this up a wee bit, so we make more of it here, so we can see the box, and we're aware of both sides of that box. So before, in the first 1 point perspective exercise, we were standing on one flat plane, which was just going one direction. Here we are looking at an object that we can see two planes, two sides, if you like, of that object. So each side is running back into a point of perspective, a disappearing point there and there. And you can see how that creates the illusion of some solidity, if you like. And of course, if you run these guidelines out from the center of these points, just like we did before, you would have lots of little guidelines. So I might use a little finer point pen for this. So if I take any point along here, this line here, and radiate it, connect it, if you like, from there to the point there, and I'm doing this freehand, which is to keep a steady hand, and from there to there, hopefully these lines are strong enough for you to see, and from there to there, you can see all those little guidelines. So I can use those, for example, if this building has windows that are straightforward. The verticals always stay vertical, of course, but what changes is the tops of the window, in this case, runs along that guideline, and the bottom of the window runs there. So here you can see the illusion of a window. Likewise, if I radiate the lines from that second point of perspective, going in that plane, so sorry, there and here, and in this case, let's say we put a little window down lower. So again, verticals depends on how wide the window is, of course. It could be a wider shape of a window, or a shape, or whatever, and then join that line and join those lines, of course, along the guideline, and you can see what's happening. And we have the illusion here of a solid box, or at least a box whereby we're seeing two sides, and we can introduce all sorts of other details and so on. Likewise, if we take this corner of the box, let's say, and join it to this point. So I'm going through this corner and I'm joining it. I'm going to make this stronger in a moment. But if I join those two together, that corner and the vanishing point there, I'm going to do this with a stronger pen. So that is joining with that. Hopefully that's fairly straight. And likewise, this corner joins with this point. So if I can make a line run, I'm gonna chicken out here, and I'm gonna use a ruler from this corner to this point, because it's a longer distance. I just want the line to be a little bit more accurate. Okay, there. What we get is the floor. You see that rectangle right there? If it was a building, let's say that would represent, if it was a glass building or a glass box, that's the floor that we could see in there. So the perspective that's happened from the inside is there also. So it may be possible, I'm not sure, if I were to fill that in to see how that creates an illusion there. You can see how that changes the things there. You're aware of that, which would represent the inside floor of that building. So you can deal with interiors and exteriors on 2 points of perspective also. So Now what we're going to look at is 3-point perspective. So we're getting into more complex stuff now, and hopefully it will all make sense. But we begin 3-point perspective in the way we began the other two. So we can begin with a line, horizontal line going across like that. We make this a wee bit shorter, this line. I'll show you why in a second, but it could go all the way across. And at the end of that, we'll put 2 vanishing points like we did in the 2-point perspective. Now the difference this time is we're going to create a 3rd vanishing point down here. So we're going to place a vanishing point about here. And I'll join these up. So I'll make it a line joining the 3 up. We form a triangle. I'm going to chicken out again. Just use a ruler because it's a longer distance. Let's join these 2 little dots together. So basically what we have is a simple triangle. That's a better line. Okay. So with 3 points. Now, just as we did with the 2-point perspective, we can begin by placing a line that might represent the corner of a building, let's say, or the corner of a box. So I could, in this case, just place a line there. That's the corner of my box this time. That's the top, bottom of my corner of the box. Again, like 2-point perspective, I can run the lines back from the top into the vanishing point. So the top of that box, corner, or building, whatever, will run back here and join like that. The bottom of that will, of course, also run to the same point. So in other words, there are radiating lines coming from that point, radiating lines coming from this point, and there will be radiating lines coming from the 3rd point in due course. But again, that corner will, of course, go to this side, running back into the distance. This corner to that side. And we can see, just like the 2-point perspective, the same sort of thing is happening, that these 2 sides, one side's running that way, one side's running this way. Now, the difference occurs when we decide, let's decide how big our box is. So the side of the box could be a little skinny box, could be a big long box. We'll make it sort of an average size box. So there, that will represent the edges of the sides of the box. So in other words, there, if you like, are the 2 edges where the building ends, if you like, or the box ends. Now the difference with 3-point perspective will be that these points on the top of the building, the top of the box, will run towards this 3rd point. So rather than simply going vertically, because if we went vertically, yes, we would see the illusion of 2 sides, but we wouldn't create the illusion that we're above, also up above this shape, above the box or whatever. So now what I'm going to do is join this point to the bottom vanishing point there. And this point to the bottom vanishing point here. And what you can begin to see is an illusion that the structure is going down, if you like. So following on from that, this point will go over that way and this point will go this way. So everything on this side of the building or side of the box or whatever it is will be running over that way, and everything in that side will run this way. So this is at the top of this box. So what I'm going to do, pardon me for slipping a bit, join that to that vanishing point. So you can see that disappearing off into that distance. Then we're going to join this one away into the distance to that vanishing point over here. Just join that up a bit. And now what we can see is the top of the building or the box. Now what we're seeing is 3 sides. So it is truly 3-dimensional. In other words, our position, our eye position, is not only at the side of the box, but also above it, which happens quite frequently. You know, you might be walking along, looking down at a box, and you can see the side there, and the top at the same time. You probably will not see the underside of it because the vanishing point's back down here. And the same thing applies to the details. If it was a building, we could radiate lines across here. So all the lines around those four sides will run that way, and lines will run that way from these sides, okay? So I can radiate lines, lots of lines, so it's a fairly thick pen, so it's hard to get lots of lines detailed in. But you can see how I've added a couple of lines there. And again, if I follow the perspective, so the vertical lines are going to this point here. They're not just running straight down. So this time I'll hinge that right at that little point, swing my ruler around, and what I can do then is place a line there and swing that around a wee bit to place a line there and create a little window. You'll see that the window isn't straight because it's running down towards the vanishing point. So we now have a three-dimensional structure: a top, a left side, a right side, whatever you want to call it. And of course, we can create space and tone by colouring these things in and whatever. And that follows on. If you continue, if the building was actually that, or the box was actually that size, then we take that edge, that point, and join it to this point. Suddenly that's a different thing there. You can see how that, if that was the edge of the box, it would be different. Then this, of course, is going to come over here. So join that to this. And you can see so on. And in theory, you can continue this all the way across here. So you can continue that sense of it being in perspective. So this building is running down away from us that way. It's running away from us that way, and also running away from us that way. And I suppose if we were to fill in sections of it, you can see that illusion maybe a little bit more obviously, but hopefully it is clear. So hopefully that will explain to you or help you understand the difference between viewpoints: one single viewpoints, twin vanishing point viewpoints, and 3-point vanishing point viewpoints. What I want to point out actually is it's the reasons why these things happen, because it's fine showing you this and saying, right, position 3 points and join up the dots if you like, and this is what you get. But yet we have to think of the logic behind this. And if you think of this as our horizon line, because this has been what we've had in common with all of the things I've drawn so far, we've had this horizontal line. That is our horizon line, if you like. It's our eye level line. It represents the level of that our eyes are seeing things, if you like. So that represents that. Therefore, in this case, the object, I positioned it down here. If you remember, the line went down here. It was below my eye line. So the outcome, of course, you can see is this little box, building, whatever, which is below the eye line. And because it's below the eye line, of course, I can see the top of it because I'm looking down on it. I can't see the bottom because it's too far down, if you like. That makes sense. So the horizon or your eye line is critical to how you form these lines and perspective lines and so on. So what I'm going to do now is just to show you what would happen if you place the building above your eye line. All right, so what I'm going to do now is reverse the process, if you like, and think about what would happen if our eye level changes. In other words, the object that we're drawing is up above us, above our eye level. So let's assume that this line is our eye level or horizon, whatever you want to call it, and the object's above. So in this case, what we're going to do, we can place a vanishing point here, vanishing point there along the horizon line or the eye level. In this case, we could place a third line, let's say up here somewhere. So what I'll do is I'll join these things together first of all. So we'll create our little triangle again. So there and there. So because we're dealing with an object above our eyes, we're working our third vanishing point up here. So this time, as we did before, I'll draw in something that represents the corner of a building, corner of a box, same sort of idea. Maybe place it just here. So there's the corner of that box, and it's above our eye line. So in this case, you know that the lines will radiate down towards the horizon, or the eye line if you like, as we did in reverse, if you like, to the one we've just looked at. So I'm joining that top, the bottom, sorry, and then the top of our box, joining the bottom of the box at that point and the top at that point. So just like the 2-point perspective, we have this illusion of something running back into space. This time we're going to do the same thing again. We'll decide on where the edges of the box might be, what size of box it is. So we'll say it's there and there, okay? So this time what's happening is the lines of this are running to that upper vanishing point. So in other words, that line will join to this top point. So I'm going to run that up there, and that line, now that edge there will run up also to the top point there. And now you can see already this illusion. It is more like a building in the sense that we've often seen, if we looked up at tall buildings, disappears up like that. What we also realize is there's a space under here, and of course if it was a box, we're going to see the underside. So it's the reverse of the previous one. So in this case, we'll join that corner, put it into the distance, into the vanishing point over here. We'll take this corner, put it into the vanishing point over there. And we can see the underside of our box. So there's the two sides. We won't see the top, of course, because we're underneath it. So our eye level is down there, the object's hovering, if you like, above us. What I'd like to show you here is one way of constructing a circular shape, but leading us to actually thinking about perspective and how we put a circle in perspective. But we'll begin by working on a flat plane, if you like, a flat, straightforward circle. If we were taking, this is a square, it's equal sides, draw a square, find the center using the two diagonals. Okay, so I'm drawing a diagonal line there, and I'm drawing a diagonal line here. Get that up there. Then what I'm going to do is split those lines. So I'm going to mark the halfway point, if you like. Get that as parallel. I'm not measuring for this. I'm going to eyeball this and hope that it works okay. Straight across there, and one through the center that way. Line that up and make a line that way. So we have this star shape. Then what I'm going to do is split this. So this half, this section here is going to be split into 3 parts, as is this. So in other words, there'll be a total of 6 splits there and 6 that way. So again, I'm going to eyeball this and see how we go. So I'm going to try to guess and use the principles that we talked about earlier about making estimations. So I'm going to split that into about a third there and about a third that way. You could of course measure it, and that will of course make sure that you'll get a more accurate circle, but what I want to do is just show the principle of this. So this is split into 3 equal parts there. Come down here and do the same with these little sections. So there's one there, then there's another one below that. And you may be thinking this is a fairly complex way to do it, and it is, but I'm trying to lead you into a method by which you can put circles and spherical shapes and so on in more of a perspective later on. Okay, so we are going to do the same thing again. We're going to split vertically these lines, so we're going to have this split 3 ways. Okay, there, let's say there and there, and again here, there, and here. So we'll make them split 3 ways. So now drop a line that way, 1, drop another line down that way, 2, sorry, like that, another one that way, and the last one. So we have a grid basically that we've built up here. What I'm going to do now is simply think, well, if we're going to contain a circle in that, the outer points of the circle are going to be those points, top, bottom, and sides. Obviously, that's as far as the circle can go, and then it curves back into the square again. So I can mark these almost little arcs. You can see there, one there, and one on either side. Now what I can do is plot some points. And if we just go around each line as follows, start from one of these arcs, go to the first line and come in a little bit, you know, and we're not being scientific here, but just come in a fraction, make a dot. Okay, now when we come over here, we're going to make a dot. You can see that that line should intersect those, but just on either side of that line where it intersects these ones. Okay, then come to there, come in a little bit, just as we did with that one. This one we know is on the outside anyway. This one, come in a little bit. Now we come to an intersection one. So what we have is we put a little dot on that line and a little dot just to the side of that. Then this one, we come in a little bit. This one we know is already there. This one, we come in a little bit. This one is an intersection. So again, we have a little dot on the side of that, little dot on the other side of that one. This one, we come in a little bit. That's set, okay. This one, in a little bit. Just make these lines a bit darker. This one is an intersection. So again, one on that side of that line and one on this side of the line. This one comes in a little bit. And if I make those dots just a little bit stronger, you can maybe, I hope, already see the construction beginning to happen of a circular shape there. Do you see around the dots? So if I've got my square right, this should be pretty circular. If I'm out slightly, it'll be slightly off circle. So obviously we'll see what happens. But now what I'm doing is gently sketch in between these points here. So I can work my way around between these and come around that way between those. And again, you can correct the lines as you go. These ones come around there into that. Arc it on round to this one and this one, and so on, all the way down to that arc here, and then back up around these two. So I'm trying to use my hand to give me a nicer gentle curve there. Oops. And you can see that we're constructing a reasonable circle. I'm a wee bit out there, but that's just my drawing. What you can do, another way to do it also, is instead of going in straight away with a curved shape, you can just join the dots. You'll get a sort of multi-sided figure, which you can then smooth off. But you can see that it does construct something. Now, the reason I'm showing you this is when we come now next to how do we tilt a circle in space, if you like, in perspective. In this case, this diagram, what we're going to do here is try to create a circle in space, tilted in and back into perspective. So what I've done is put some guidelines down, just as I did when we looked at 1 point perspective. So we have a horizon line here, we have a vanishing point right there. I drew a line here to represent one side, if you like, of a rectangle or square, and connected it with the vanishing point so we can see that. And there's the other side, if you like, of a rectangle or square, I should say, right here, tilted into space. So what I'm going to do temporarily, or at least just to help me see things a little bit, I'm going to rub out that middle line, the line that was part of the horizon line, simply so that I can see it a wee bit more easily when I'm drawing the other guidelines. But you can see here, there's our flat plane, okay? Begin as we did before in the previous example with creating or finding the center by connecting the two diagonals, so there and here. And keep in mind that when we talk about perspective center, that is different from, if you like, center when it's flat, if that makes sense. In other words, you can see that that point there is not halfway between that line and that line, as it would be if the square was tilted flat onto us. So because it's tilted and running back into space, the perspective center is different. It's a mistake that some people still make. What I'm going to do now is create a line through that center as we did before, but this time it's got to radiate from the vanishing point, of course. So that line's got to come that way, all the way back to the vanishing point. Just try and get that right on the button here. So that's a darker line going back there. Then same thing vertically, but in the case of the vertical one, it just simply will be vertical because it's 1 point perspective. Okay, so we're only looking at one vanishing point, so we'll draw a line that way, and what we've got is our little star shape, if you like, tilted in space. Now what I'm going to do, and I could rub this out if I wanted to, but we'll push on. What I'm going to do is, as I did before, split the horizontal lines, 3 there, and a total of 6, if you like. So I'm going to eyeball this. I'm not going to measure it. So, you know, you can measure it, of course, to be totally accurate. But for the sake of speed and, if you like, a challenge, I'm going to try to see if I can get close in with the thirds. Okay, by eye. And I'm going to make that about a third there and about a third here. And then split those across, again radiating them to the vanishing point there. Get on to that, just there. And yes, this is, if you like, quite technical in a way, and those of us who are painters and artists, whatever, maybe don't see ourselves spending lots of time doing things like this, possibly, but I think it's quite important to be conscious of why things happen, because sometimes you do try to work from instinct and it works pretty well, and then there are times when you just can't seem to get the solution, and you can fall back on these systems to do that. So we've got our horizontal split, if you like. Now what I'm going to do is I'm going to look at the intersections. You see where that line intersects that, and that line intersects that, and I'm going to join that one up. Okay, so just going to very carefully line that up and run a line through those. Okay, so I'm going to look for the next one. The next intersection is there between two lines and here. So what I'm going to do is join that up. So line that. You can almost hear me concentrating here. Then we have the center line anyway. Then we come to the next intersection, which is here and here. Connect that up. come to the next intersection, which is here and here, and connect that up. And I think what we will see, it's maybe not quite as straight as it should be, but what you'll see is that these boxes get smaller and smaller and smaller as they go back. So that follows on from our principles of perspective, okay? Now, following on from our last example, when we used a square and to create a circle, we'll do the same thing. We know that that's going to be the top of our ellipse because it's not a circle anymore. It's going to be an oval or an ellipse. That's the bottom because that's the center point. There's a center point there. So that's going to be the outermost edge there and there. So we know those four things. What we'll do is we follow the same principle as before. The first line, come in slightly a little bit. And that's why it's not mathematically accurate. Well, a little bit doesn't really make sense, but you can see it's just a fraction in. Then we have our first intersection, put a dot there. Next line, in a little bit. We already have our line here. We know that's the outer line, the outer limit. Next one, in a little bit. Next one to the intersection dot. Next one is there, in a little bit. Next one is the outer line anyway. Here we go in a little bit. Intersection. In a little bit here, that's the outer line. Up here, in a little bit, that's the intersection. And here we go in a little bit. So perhaps if you can see, and I'm making them darker, these lines, or sorry, dots, you will get some sense, I hope, of an ellipse appearing. Okay, do you see around these lines? So I'm going to very carefully attempt to connect these. So the ellipse changes as we know down there. Then it starts to curve up. So let's get the upper part done. Round to there. And there, I'm going to give that a wider curve right there. Then out to the outer line. And we know, I mean, we will need to correct certain elements of this, but we've got lines to join up, if you like. And you can see here how I'm going to begin to make that a little bit darker as I find my way into it. There's the curve there. There, and as I said before, ideally it'd be easier to swivel the actual page around, but go out to that outer one there, that's where it should be. But because I've taped the page down because of the camera, that's harder to do. But we can begin to see, I hope, the ellipse that we get to represent that circle in space, if you like. That's a little bit off there. That top section looks a little bit like it needs to just come out a wee bit more there. But we have a guideline there to create something that gives us a sense of space. Could be a wheel, a car wheel, it could be whatever. But at least it is following some sort of a pattern, if you like. If you can imagine, and what I'm going to do is imagine a second vanishing point. Now we're getting into 2-point perspective, but just wanted to show you something here. If I put a little point there and take the point, the apex, the point of that ellipse, and just join it to the vanishing point here, and take the same idea, the very ellipse, the very lowest part I can get here, and join that. So just run a line until it touches, intersects or sweeps past the ellipse. And you can see then, if I was to echo this shape here as best I can there, we can create, I'll rub out the guidelines and maybe help us make, we can create a sense of something that is solid. It could be a lid of a bottle, it could be a tire of a car. which is running back into space there. Well, if that's making, yeah, it's beginning to make sense. Okay, it's not too bad. So get rid of some of these just to isolate this thing here, and maybe you can see it more clearly. So there we are with this solid elliptical shape or circular shape tilted in space. Could be a hinge on there or a little axle if you like. So hopefully that gives you some sense of how we can create three-dimensional spaces, circular type shapes if you like, elliptical shapes in space using a known method. One of the most frustrating things can be how we judge when verticals get closer and closer together as they disappear into the distance. So we know that things get smaller as they disappear into the distance, but they also get closer. I'm thinking of railway tracks or railings or lampposts or trees placed at regular intervals. When they go back into the distance, they appear to contract smaller and smaller and smaller, those spaces, which gives us the illusion of depth. How do we judge that? How do we actually find out what that difference is? Well, what I've done here is I've created a horizon line just like we did before, a vanishing point again like we've done before, and I've drawn a line here which, let's say, represents a lamppost. Okay, what I'm going to do then is join the top and bottom as we did in previous exercises to the vanishing point. It's little guidelines there, so join that to that. So there is our fence post, lamp post, whatever. Let's then place in our second lamp post. So we decide on a certain distance it's going to be, we'll call it that. And of course, this lamp post will be smaller because it's running along the line towards the vanishing point. From here on, how do we judge the reduction in those spaces? What we do is we find the halfway point of this first lamppost. I'm hoping I've made it a reasonable measurement that I can mathematically calculate. It's 5.5. Okay, so that's what, 2 3/4. So if I come up 2 3/4, that's inches, of course. So there, and then join this to the vanishing point. Okay, so that halfway point is joined with a guideline to the vanishing point. Sorry, shake at the end there. It's a wee bit better. So there's a line going off the vanishing point. From here, it's simply a matter of taking the top of that first lamppost, we'll call it, through the point where that second one intersects that guideline we've just made. So from there to there, we'll draw a line and it lands right there, which tells us that's where the next lamppost will be. So what I'll do is draw a vertical line there to represent the next lamppost. So that's that. The same again, this time I'll draw from the top of the second lamppost through that intersection there of the vanishing point. So from there to there, let's get that in, and that lands here, and that's our next lamppost. So I'll make another vertical line at that point. Then from this one through that intersection, and we can see, I hope, slowly but surely, the reduction in the spaces between each lamppost. Again, do that one through this. Get that steadied up. There, then that's that one. And we can keep going as long as we want. And we will probably end up becoming really very, very close. So I'll do one more just to see how that changes things. So you can see that. So you can see how it's becoming really quite thin. And there is our increasing or decreasing space between these lampposts. So you can imagine a lamppost is well drawn, but you can see them disappearing back into space along a street, or it could be a line of trees or whatever. But we have these spaces accurately gauged when we're painting or drawing an urban landscape or something like that. Now let's imagine that we have a situation where we've drawn something like the side of a building or a box or whatever, which actually extends off the page or canvas. In other words, the vanishing point is not anywhere on our page. So we know this is a line going into the distance. This is a line running down, let's say, the corner of a street, and that's the other street at right angles to it running off that way. But the lines that converge are not converging on the page. So in other words, the vanishing point, if we kept going, eventually would be way out here. In fact, you can't see my hand beyond the screen. And likewise there, if we continued, we go right off the page. It could be many feet, many meters away perhaps. So if we decided we want to draw a door in here or a window, how can we calculate where to lead our line? Because we have no vanishing point to work from. Very simple method is called the Brewer method. And it just simply means that if, for instance, I want to make the top of my window, say a third of the way down this line, about this height. So what I'm going to do is measure this height. It's 12 centimeters. So let's say I come down a third, which takes me to the 8 centimeter mark, which is just there. I'll make that line dot a little stronger so you can see it right there. Then what I do is come over here, draw a line very, very close to the edge, but not quite, and measure that. So that line is 6 centimeters. So if I measure a third of the way down there, it's going to be 2. So 1, 2. There's my marker there. And of course, if I join these, I'll have a line which should be in keeping with the rest of the perspective lines. So let's say the bottom of a window is 2/3 of the way down. So we'll go 2/3 of the way down this line, which takes me there. And I'll go 2/3 of the way down this line, which takes me to here. Join those lines together. Make them a little bit stronger so you can see there. Lean a little more heavily. And so you can see that line and that line. And of course, the verticals of the window would remain vertical, of course. It could be a doorway, it could be any structure. But if I do that, I'm doing this by eye here, so hopefully I've got these pretty vertical that you see. So let's say we've created our little window in there, which sits in that space and is in keeping with the correct perspective. So it's simply a matter of whatever percentage you come down this line, you come down the same in the line near the edge or at the edge possibly if you want. And of course the same applies in the other direction. Another interesting challenge is where we have a changing vanishing point. What I mean by this is an example would be where you have a road which is turning or bending. So in other words, we have so far talked about vanishing points in terms of 1 or 2 point perspective. In other words, there's our horizon line. I could, for instance, put a dot there, let's say, and call that my vanishing point. And what I'll simply do is draw a little line there, keeping it slightly lighter because I want to perhaps change that shortly. And another line there. And we have a very traditional, if you like, railway track idea off into the distance, disappearing at the vanishing point. But let's, for instance, assume that halfway along the road, as it were, the road changes direction. So therefore, assuming that the road is lying flat, it's not going uphill or downhill, it will then have a different vanishing point at that point, if you like. So let's assume that, say, from about here, I'll just draw a little line across there, there's going to be a turn in the road and it shoots over that way. So what I'm going to do here is put a vanishing point about there and then join these corners, so that the ends of this line here. So if I put a line between that and my vanishing point there, and then a line between that one and my vanishing point here, I now have a turn in that, so it might be easier to see. I'm going to attempt to rub this out. Hopefully the rubber's fairly clean, but I'll rub out these middle sections here where the guidelines were, and I'll rub this out where I had the original vanishing point. I'll just replace that. That should be in there actually. So we've got that turning that way, and then off into the distance. So you can see how that looks in terms of a road that's turning. And of course it could turn several times. You might decide that about this point that will turn again. So if I make a line across there horizontally and decide it turns back and there's another vanishing point, what I could do then is put that there and that here, and create another vanishing point, and then this time take this out and take this middle section out here, and you can see that we're creating a turning road, and in theory that can continue for some time all the way up, and that's assuming that the road is flat and it's not going up the hill or downhill. Now if we have a road which is going uphill or downhill, that changes the picture again. If we have a road that is flat in front of us, as we've stated before, it will just disappear to a vanishing point. So I'm going to draw something like that there, and let's say there. So that's again our traditional flat road off into the distance. If the road, let's say, is running downhill, it will disappear to a point below the horizon line. So in other words, I'll take the same measurement here, which is just 9 3/4. So I'm going to do the same there. I want the measurement to be the same for both examples. So if I take that, but this time bring my vanishing point lower, then of course the result will be a more squat triangle, if you want to call it that. And our viewpoint, get that a little bit darker there, will be this rather than that. In other words, if you see it as a flat road, let's say we have a tree across it at that point, okay, and take that same tree, the same distance from us, across this at that point, that's what we'll see if we're looking downhill. So that's our flat one, that's downhill. And I might have just enough space to work one uphill. I'll try that and see, it might be narrow. In other words, the uphill one will have a vanishing point higher than the horizon. So I'm going to draw that in. It's a bit clumsy, but we'll do it anyway just and see how that looks. So you'll have a shape which is a more elongated triangle, unlike the one beside it. And if you imagine your little tree at this point here, same point, but we're looking that way, that's us looking uphill, that's looking downhill, that's on a flat road. what I want to do now is point out a couple of ways in which we can identify uh, vanishing points, if you like, and eye level. So here's a picture of a kitchen, all right? What I've done, and you can see lots of lines in it and lots of objects, clean lines. What I've done is I've put in some guidelines. So if we have a look at that, see if you continue the uh, the lines on the edge of the tables and the workbenches and so on that are disappearing back towards the facing wall, they're appearing, as you can see there, in a point somewhere just along that cupboard, just above the bottom of the cupboard, if you like. Now, you could look at many other lines there and you'll see other lines radiating. But if those objects are running at right angles to that wall and they're on the same plane, they will appear to land in that point. Now, another way to find that level, which is your eye level, is simply to take an object, or in this case, if you take a piece of cardboard or paper, preferably cardboard, flat, and hold it at right angles to yourself. It's no good if it's tilted. Got to have it coming right out, as if like a little peak of a cap that you're wearing. It's coming out at 90 degrees from yourself. And if you hold it in front of yourself like this is below eye level. So therefore I can see the top of the piece of card. If I raise my hands up, keeping them at right angles like that, and I go too high, of course I'm going to see the bottom of the cardboard. If I bring it gently down until it's smack in line with my eyes, that's what I get. You can see now that if you look on the right hand side, beg your pardon, if you look on the right hand side, you'll see where that piece of card is right on my eye line, right at my eye level. And if you compare it to the earlier image of where the lines radiate, which is on our left there, you can see they're pretty much the same. They should be the same. So there are two methods. If you're looking at a place or an object and you want to find where is this vanishing point or where is my eye line actually, there are two ways you can do this. Now here's another variation of this theme. I've taken another photograph, as you can see, and this time rotated the small table so that the table actually runs in a different direction to those other lines on the worktops and so on. So what you can see are two or three points of vanishing points. If we follow the line, for example, along the edge of the little small table, it will come up to a point up there, which is on the yellow line, which is my eye line. If we look at the lines running that way from the little table, they will also land up there at the point of the yellow line. And then if we look at the lines coming from the fixed objects like the workbenches that are running directly back towards that wall, they will also converge at a point along the same line, which is my eye level. Okay, what I'm doing here is taking my pencil, as I would if I was measuring something, straight ahead of me and straight upright. And with one eye closed, just rotate my hand, twist my hand until the pencil runs to be in line with the edge of the laptop. So at that point, I will carry that angle across to my drawing board and make a mark at that angle. Here I'm doing the same thing with the edge of the table, so looking along my pencil, arm's length, of course, locked out arm's length. Rotate your wrist until it runs in line with the edge of the table. You can go back and forward and just check that. And once that's locked there, then carry that angle over to your page and make a mark just like that. we haven't really spoken about aerial perspective. So this is a very brief outline of it, just to remind you that it's the illusion of space and depth and distance by color, or through the adjustments in color, if you like. And in front of you here, hopefully you can see a photograph, which is a great example of this, a very good example of what happens. And basically what happens is the atmosphere in the Earth is such that it filters color. So the greater amount of atmosphere between us and an object, then the more filtering gets done, and therefore the color gets changed, usually drained and lightened and so on. And this photograph is a great example that as we go back hill by hill, mountain by mountain, you can see the changes. And the three main changes are a change in brightness. Generally speaking, objects will appear a little bit lighter as they go closer to the sky, further away from us. They will also generally get cooler. So a blue back here in the distance will be bluer and colder blue than the one closer to us. Reds equally will lean towards purples because they become a colder color. And then we lose saturation. The richness of the color is drained away. It becomes grayer, if you like. In other words, there's less color in there. And those three things usually happen. There are variables with certain atmospheric conditions and weather conditions where mountains may seem much deeper in the distance and so on, but generally the rule is that any object going further away will respond to those rules, if you like. And you can see it here perfectly in this example. What I did was I sampled little colors from this picture, and I'm going to attempt, if you bear with me, to show you what I mean. What I did is take a color here. I'm going to paint it by the side of it. You can see, hopefully if you look to the left hand side, the sample of color, which is from the first phase there. Then just above it, I'm going to paint in that little patch there. So you can see them as patches almost of paint rather than part of the photograph. And again, there, I'll bring that a wee bit further or closer up to that. And then that color. It's a little bit lighter again, a little bit, put it closer so you can see the difference. It's actually touching it, to be honest. So there are 4 color samples that I took from that photograph. And you can see when we isolate them, the changes that are happening. So if we look over here at this patch, you can see the change in brightness. You can see the change in grayness. And you can see the change in coldness. So the blues here, certainly this blue, is beginning to go towards what we would call purple blue. You know, it's got a redder content, and indeed this one also, it begins to get redder. But basically from there back, the blue becomes colder, becomes lighter, and becomes grayer. And those are the things you would do when you're mixing your colors, and that applies to any color. What I'm going to try to do maybe now is do this with a different color. I've probably set myself a insurmountable challenge here, but I'm going to try to with the side of this here. So what I'm going to do is take, say, a red. So I'm going to take the red. I'm going to take and put that on my palette here. So I'm going to mix a bit of red on that palette. What I'm going to do is put that on first. So up here, there's a patch of red, very bright red. Now what I'm going to do to this red, go back to our palette here, have a look. What I'm going to do is make it a little bit lighter. So I'm going to get myself some white, put a little white in there, rinse the brush, stir that together. So you can see that slightly lighter. And I'm going to add also a little bit of gray in there. So I'm desaturating it and I'm lightening it. So you can see the color that I've achieved here. I'll put that beside that one, okay? So you can see that Could be a wee bit lighter actually, but certainly desaturated. Put a block of that there. Go back to my palette, and again, what I'll do is add more white this time, so it's much paler. And tiniest amount of grey this time in it. Stir that in. You can see something happening, and hopefully you'll see it when I put it here, that the red is not only getting a wee bit lighter, but it's also looking slightly more purple, which is the coolness of it. So you can see that from the first red to the third one, how it's becoming more purple. So what we'll do is one more, add some more white in there, stir that together. Really, maybe add a little bit more actually. Stir that in there, and then a tiny minuscule bit of grey. Put that in there. So we really have a very grey, sort of slightly purple colour. So there you can see that cooler, slightly lighter, and beside that one. And just for the sake of it, really, because I'm enjoying playing with this, a little bit more white, and just show a slightly lighter version of that. Actually, a lot more white, to be honest with you. There we are. Put that in, stir that around. So we're really becoming very hazy there. So there's a lighter tone. And you can see, like the blue, if we look at these now, if you look over here, and hopefully the pointer is there, you can see the blue receding as it's coming from the photograph. There's my red version and how it would recede into the distance. So those are the rules that you can apply to create aerial perspective. And sometimes the two types of perspective can be combined. In other words, linear, you have your angles running back in the vanishing points like a box, but the sides of the boxes can be varied in tone as well to emphasize that spatial illusion as well. So hopefully you'll find that of some interest. What I'll do is I'll bring myself up just to say hopefully this video has been of use to you. The whole video, please look at it in parts. It's a long video, so look at it bit by bit. And on the day of our workshop, what I'm intending to do is do some little exercises picked out from those things that are in the video, and hopefully that'll emphasize our learning experience. So thanks for watching this, by the way, and I'll hopefully see you soon. Okay, bye.